Hello, my name is Lucy Barker. I'm a hydrologist at the Centre for Ecology and Hydrology in Wallingford, and I'm going to be talking today about historic hydrological drought data and a Hydrological Drought Explorer. So firstly, we'll maybe think about what is a drought, and droughts generally occur when there is less moisture available than expected. And these deficits in moisture can occur when we've got deficits in rainfall, in soil moisture, groundwater and stream flow, all leading to different types of drought. And today what we're really interested in is hydrological droughts. And that's when we have lower river flow than we would expect for that time of year. Why are we interested in historic droughts? Especially when no two drought events are the same in terms of their timing, their characteristics and the spatial extent that they affect. Well, we need to understand the past variability to understand and detect changes in the future. And we also need to understand historic droughts because that helps us to inform planning and management for future events. For example, this is particularly important in UK drought planning for the water supply sector, where historic droughts and the worst droughts on record are used to inform their drought plans. There are lots of different ways to characterise droughts and historic droughts, and the way that we chose to do this was to use the standardised streamflow index. This is a drought indicator which is one of many, and it's part of a family of standardised drought indicators, all based upon methods derived for precipitation. And these methods all use the same kind of calculations, which basically give you the standard deviation from the long-term mean, basically showing whether it's wetter or drier than normal for that particular month. So we have negative values when it's drier or their flows are lower than normal, or we have positive values when it's wetter than average or flows are higher than normal. And those indicator values can be associated to different severity categories, but the more negative the values, the more severe and the less likely that is to occur. Some other benefits of using the standardised streamflow index and these other standardised drought indicators is that they're comparable over time and space. Because we have different variations for different variables like rainfall and groundwater, we can compare the drought characteristic across these different variables and these different parts of the hydrological cycle. For example, you could look at the Standardised Precipitation Index, the SPI, on the UK Drought Portal, which is available at this link, which is updated in near real time and allows you to look at rainfall deficits across the UK. And we're looking to add streamflow and groundwater data to this, so you can really monitor droughts across the UK in a holistic way and look at deficits in rainfall, river flow and groundwater in a comparable way. One really great thing about these standardised indicators is that you can calculate them for different accumulation periods, whether that's the 1 month, so you're looking at kind of instantaneous deficits in flow or precipitation, or whether you're interested in longer periods, maybe like 3 months, if you're interested in seasonal deficits, up to 6, 12, 18, 24-month deficits, depending on the type of drought you're managing and the resource that you're managing as well. And as I mentioned, they indicate the severity and the probability of deficits in flow. And these indicators, the SSI and associated rainfall indicators, are really used quite widely internationally, but haven't been used too much here in the UK before. And so we've been doing some work over the last few years which look at the best ways of calculating these indicators here in the UK and what they show in terms of drought characteristics and drought propagation using observed data. But these observed data, which we hold on the National River Flow Archive, generally only start in 1961. And we know in that period before 1961, there were some pretty severe drought events which had wide-ranging impacts on the environment, society and water supply. So within historic droughts, we've been looking at, we have derived the standardised streamflow index from 1891 to 2015. To calculate these data, we used historic reconstructions of daily river flow for 303 catchments, which Katie Smith has produced, and those data are available to download for free from the Environmental Data Centre. And there's also a video you can watch where Katie describes the modelling process and shows you how to download the data and explore those data as well. But the standardised Streamflow index for these 303 catchments is also freely available to download from the EIDC, and I'll show you how you can download that later on. But so these time series show us the deficits in flows, or the excesses in flows from 1891 to 2015. But if we want to look at the individual drought events, we first have to extract those events from this time series. And the way that we did this was to define a drought event as a consecutively negative period of SSI values with at least 1 month reaching or exceeding a given threshold. We've used 3 thresholds to extract events: -1, which equates to a moderate drought, -1.5 equating to a severe drought, or -2 equating to an extreme drought. And if we use the -1 threshold, we're going to maybe identify quite a lot of droughts, because they're going to occur more commonly than events with a value reaching -2, because that's much less likely to occur. For each of our extracted events, we can calculate a range of event characteristics. We have the duration, simply just the number of months within that event; the accumulated deficit, which is the sum of the SSI values within that event. We can look at the mean deficit, the accumulated deficit divided by duration, which gives us an indication of whether it was a short, sharp event, or kind of a very prolonged event that is maybe just rambling on, and not too severe deficits and flows. Then we have the maximum intensity, which just gives us the minimum SSI value within that event. These extracted events can all, and the SSI time series for the 303 catchments, can all be explored within the UK Hydrological Drought Explorer, which I will show you in just a second, and is available at the link on the screen. But if you want to find out more about the model flow reconstructions, you can look here at the Reconstructed Flow Data Explorer, which gives you information about how well the models are performing in each catchment, which is particularly important when we're thinking about using model data. We want to know that the model data is actually representing the observations well. So before you dive in and use any of the SSI data, I really recommend that you have a look at the Reconstructed Flow Data Explorer for your selected catchment. So next, I'm going to show you how you can download the data from the EIDC, the Environmental Information Data Centre. You'll need to log in and register for the service, which is entirely free. But once you're logged in, you can go to the data page here and click download the data. You'll get a page here which lists the files available, which is one for each of the 303 catchments, and they are identified by the National River Flow Archives ID numbers. If we go down, we can select a catchment, download it. We can see here in the CSV we have columns for the 7 different accumulation periods available: 1, 3, 6, 9, 12, 18, and 24 months. And because these accumulation periods are calculated for the end month accumulation period, we have some NA, or -999 values. So for the 3-month accumulation period, the first 2 values of the time series are NAs and don't exist because they've been used to derive the SSI value for March 1891. Similarly, if we look at the 24-month accumulation period, we have 23 NAs here before we get to our first SSI value in December 1892. Also, on the data page, we have some information on how the data were derived, and you can also download some supporting documentation which will give you a lot more information on the calculations used to derive the data. Now to the exciting bit where we're going to look at the UK Hydrological Drought Explorer app, which allows you to look at the SSI time series and the extracted events for all of the catchments. So on the first page here, we have a map of the 303 catchments for which data are available. On the left here, you can choose which catchment you want to look at, and the map will update to show you where that catchment is. Once you've selected your catchment, you can go to the catchment plots page, where you will be able to look at a time series plot of your selected catchment and an accumulation period. You can change the accumulation period and the map will update. You could change the time period you want to look at. The default is for it to look at the full time series 1891 to 2015, but you could look at 1910 to 1950, and the graph will update to just show that period. If you scroll down, the graph below shows simply just where the extracted drought events occur in that time series. And if we remember, a drought event was defined where we have negative SSI values with at least 1 month reaching our given threshold. So by default, we're showing the severe droughts with a threshold of -1.5. And we can see here we have quite a lot of drought events identified within this 1910 to 1950 period for our selected catchment. Then at the bottom of this page, we can look at the extracted events, but we're here plotting with the time on the x-axis, but we're showing duration on the y-axis. So we've got a very long event here in the kind of early 1940s. The size of the dots is the maximum intensity, so the lowest SSI value within the event, and they're coloured by the mean deficit. So it's just quite a long event, but it was maybe in terms of the SSI values per month is maybe not so severe compared to this event right down in 1929, which was quite short, but obviously had some very severe SSI values in there. So we can look at all of this information, or we could look at a different catchment and look at the same information for your selected time period, accumulation period, and event threshold. Next, we can look at how those extracted events rank in terms of the different event characteristics. So for your selected catchment, accumulation period, and event extraction threshold, we are ranking the events by duration and showing the 10 most severe events. So for our selected catchment in the northeast of England, the most severe event, the longest event on record between 1891 and 2015 was in 1995 to 1998. Whilst if we rank by accumulated deficit, things maybe haven't changed so much, but we can look at another characteristic, the mean deficit. That ranking changes quite substantially, and in fact our most severe event now is 1955 to 1956. And the plot at the bottom underneath the table is just showing you where there is a darker red being the most of your selected characteristic, and the pale yellow being the 10th, ranked 10th. So we've been looking at individual catchments so far, but we are now going to look at things on a more regional scale on the Regional Analysis tab. The graph might take just a couple of seconds to load for you, but it will appear. And for your selected accumulation period, what we're looking at here is for each region that was shown on the map on that introduction page, the percent of the modelled area that's in drought at any one time. We have 9 regions across the UK, so when 100% of the modelled area of each region is in drought at the same time, our bars would go up to 900 on the y-axis. And for example, for Northern Ireland here, the green at the bottom, we can see that actually 100% of the modelled area is in drought several times throughout our full period of record here. This graph is quite exciting. It allows you to zoom in to a period you're interested in. We've got here in the 1930s and 1940s, we have almost 100% of each of the modelled areas in drought in 1929, in the mid-30s, and also in the late 30s, here under the key. So you can hover over and it's going to tell you the percent of modelled area in drought in any one month. We could change the accumulation period if we may be more interested in deficits just at the 1 month scale. You can see here in the start of 1929, we have almost 100% of the country in drought at any one time at that time. And we can zoom in and see how that changes maybe by the regions before and after that very intense event there. We also have some summary maps at the bottom, which just plot up the regions for the start months of seasons for each year in the series, and you can scroll through and see how maybe that changes across the year in more in a map. The information we've shown so far has been taken from the best model run of the reconstructed flow ensembles. But because we're looking at modelled data, there's a lot of uncertainties associated with that. And what we wanted to do was look at the uncertainty associated with the model reconstructions and how that affected the SSI calculations. So for a handful of catchments, what we've done is we've calculated the standardized streamflow index for the top 500 runs from the ensemble for a subset of accumulation periods. We've only used a few catchments so far and a subset of the accumulation periods because it takes quite a long time to run. We're currently setting this up for the 303 catchments and some more accumulation periods, which will be running on a supercomputer. So it will run a lot faster than running it on our desktop machines. But for these case study catchments and for your selected accumulation period, what this graph is showing you is the reconstructed SSIs in the turquoise compared to the SSI as calculated from the observed flow data from the National River Flow Archive. And again, this graph allows you to zoom in to a time period. So if we look here where the observations start for the Avon, we can see that the best model run in the dark turquoise here, and the pale shading behind it is the range of the ensemble. And we can see how that compares to the observations in the orange as they go through time. You can look at different accumulation periods because the uncertainty might be different, and how the model performs might change the representation of the model data compared to the observations, and maybe see how different catchments perform and whether there is more or less uncertainty. And we can see in this groundwater dominated catchment in the southeast of England, the range of the ensemble is much narrower. So maybe there's less uncertainty with the modelling, but maybe how it compares to the observations differs as well. So there's a lot of things to take into consideration, but if you're interested in how the models perform, I really recommend that you look at the Reconstructed Flow Data Explorer, which you can find a link to on the About Data page at the end here, as well as links to download the reconstructed flow data here or the standardized streamflow index data that's been used throughout this map. So I hope you've enjoyed this quick run through of the Hydrological Drought Data Explorer and the standardized streamflow index data that are available to download. If you have any other questions on anything you've seen or I've said today, please let me know and I'll be happy to get back to you. Thank you.